Hello viewers and welcome to our series on 3-dimension geometry. Today we will discuss the shortest distance between two lines. Now if you think of two lines which are intersecting, then the shortest distance is always 0. If two lines are parallel to each other, then the distance which is the shortest distance is the perpendicular distance of a point on one line to the other. So, is there another possibility? We are talking about 3-dimension. We are talking about lines in space, and therefore, there is always a possibility that the two lines are neither intersecting nor parallel. Such lines are called skew lines, and we are interested in learning how to find the shortest distance between such lines. Let us take a look at what skew line means. We define two lines to be skew lines if they are non-parallel and non-intersecting. Now, suppose we look at again the room where you are sitting. Can you identify two lines which are skew? Lines which are neither parallel nor intersecting. If you look at the edges of these walls which are in the same color, then these lines will be neither parallel nor intersecting, and therefore, they are the skew lines. Another example in this illustration, if I take a line which is along the railing of the balcony and I take a line along the stick which is lying inclined to the floor resting against a particular wall, then these two lines will also be skew lines. We are interested in finding the line of shortest distance and then the shortest distance. If I have two lines which are skew lines, so use your spatial skills to visualize these lines L1 and L2 as neither parallel nor intersecting, and if you can think of a line which is perpendicular to both L1 and L2, then such a line is called as the line of shortest distance, and the distance PQ which is intercepted by the line L1 and L2 on this line of shortest distance is called the shortest distance between the skew lines. We are looking at a relation between two given lines whose vector equations or later Cartesian equations may be given. How do we find the distance which is the shortest distance between these two skew lines? So, to start with, if I take the figure and take the point S and T to be the points which are given with the position vector A1 and A2 and PQ to be the shortest distance, then the projection of ST along the vector which is defining the line of shortest distance will give me the shortest distance. So, the projection of ST is what I am interested in calculating, and for that we first determine what is the vector PQ. Now, vector PQ is a vector which is perpendicular to both L1 and L2. In magnitude, it is say d units, the magnitude of shortest distance which we are in search for. The direction of PQ will be same as the vector n cap, which is known to be perpendicular to both B1 and B2 vector which are defining the two lines. And we know that the cross product of B1 and B2 gives us the direction which is perpendicular to both the vectors B1 and B2. Therefore, the unit vector n cap will be B1 cross B2 divided by magnitude of B1 cross B2. Vector algebra also taught us that if theta is the angle between the vector ST and vector PQ, then the projection, that is PQ distance, will be same as ST cos theta. Cos theta using the dot product comes out to be same as d n cap dot A2 minus A1 upon d times the distance st. We know that n cap is B1 cross B2 by magnitude B1 cross B2. So, if I replace that here, I know how much is cos theta. Therefore, the shortest distance, which was given the symbol d, is PQ, defined as a projection st cos theta. So, if you multiply the above quantity with st, you get an absolute value of B1 cross B2 dot A2 minus A1 upon B1 cross B2. The absolute sign is considered because the direction of B1 and B2 is not known to us. So, you may end up with a negative quantity there in the numerator, and that is the formula that we will now be practicing with our next two questions. You also must note that this is one of the very important formula result which is very often tested by CBSE as well. So, you need to be little ready with it. At the same time, it is an easier relation to know once you have done a practice or two. Let us see what the question says. Find the shortest distance between the lines whose equations are vector r is equal to I cap plus 2j cap plus 3k cap plus lambda times I cap minus 3j cap plus 2k cap, and the second equation is r vector is equal to 4I cap plus 5j cap plus 6k cap plus mu times 2I cap plus 3j cap plus k cap. So, if I relate these two equations with the general form that we had, then I know that the vector A1 and A2 are the coordinates of the point that are lying on the line. In this case, the vector A1 is I cap plus 2j cap plus 3k cap. Vector B1 is the vector which defines the direction. So, that is coming as the vector in the equation which is multiplied with lambda. So, that is I cap minus 3j cap plus 2k cap. Similarly, we know vector A2 and vector B2. What I need in the formula is B1 cross B2, I need A2 minus A1 vector, I need the dot product of these two, and I need the magnitude of B1 cross B2. So, it is a very simple straightforward calculation, all based on what you must have learned in the vector chapter. So, if I find what is A2 minus A1, I would get 3I cap plus 3j cap plus 3k cap. B1 vector cross B2 vector is nothing but the calculation of the determinant, where the first row is I cap, j cap, k cap, and then you write the components of the vector B1 in the second row, vector B2 components goes in the third row. Expand the determinant very carefully, an error here can affect the entire calculation. Once you have B1 cross B2, then we find the magnitude of B1 cross B2, which in this case is simplified root of 171, same as 3 times root 19. So, I think now we are ready to look at what we want. We just need A2 minus A1 dot B1 cross B2. If you find the dot product, it turns out to be 9 in this case, right. We are multiplying the components of A2 minus A1 and B1 cross B2 correspondingly. So, I get minus 9 into 3 plus 3 into 3 plus 9 into 3 results as 9. So, what you have to now do is just plug in the values of each of these in the formula, and the shortest distance comes out to be 3 by square root of 19 units. Given an equation in vector form, it was easier to use the formula because everything is easily related. Of course, the same formula can be translated into Cartesians, but it becomes a bit cumbersome. So, I will advise you to look at a Cartesian equation of a line and get the required information by translating the Cartesian into the vector equation, and then use the formula of shortest distance as we have done in our earlier question. So, suppose now I show you an example of equations given in Cartesian form, and we have to find the shortest distance between them. The question here has two lines given as x minus 4 by 1 equal to y plus 1 by 2 equal to z by negative 3, and the second line is x minus 1 by 2 y plus 1 by 4 equal to z minus 2 by negative 5. So, what you all have to do is translate these equations into the vector form. So, we know the known point on the first line was 4, negative 1, 0, and therefore, our vector is equal to 4 I cap minus j cap plus lambda times. Direction ratios of the first line are 1, 2 and negative 3. So, it will become I cap plus 2 j cap minus 3 k cap, and therefore, the same way second equation translates as r vector is equal to I cap minus j cap plus 2 k cap plus lambda times 2 I cap plus 4 j cap minus 5 k cap. And now, we are ready to find what is A1, B1, A2, B2 all as required. These vectors can be identified without writing the vector equations as well. So, if you are confident of doing that, go ahead and simplify as required. So, we are ready to find what is A2 minus A1, B1 cross B2, need the magnitude of B1 cross B2, need the dot product of A2 minus A1 with B1 cross B2, and plug in the values in the shortest distance formula. That gives us, in this case, as you can see, the numerator turns out to be negative 6. That happens because of the orientation of B1 cross B2. Therefore, the absolute value sign is important, and it gives us the shortest distance to be same as 6 by root 5 units. Now, we did say that distance between two parallel lines can always be calculated using the point on one of the line and then finding the perpendicular distance of that point from the other line. We did demonstrate this in our previous lesson as well. But can I use what we have just discussed right now in the same manner and see what the shortest distance between two parallel lines be and get a formula which is easy to use? Yes, you can. So, let us just look at the result. If I take two lines which are parallel to each other, then their equations will look like vector r is equal to vector a1 plus lambda times vector b, and r is equal to vector a2 plus mu times vector b. Note that you have the same vector b in both the equations, and therefore, if I take these two lines now, they are now parallel to the same vector b. S and T are the points with position vectors vector a1 and vector a2. So, if I draw perpendicular from T, then the distance Tp is the required one. Now, this distance Tp can be calculated using again the vector algebra, where we learned that if I take B cross vector St, the B is the vector which is along which the lines are defined. Then B cross vector St is magnitude of B, magnitude of St, sine theta into a unit vector n cap, which is in the plane of the lines L1 and L2. Now, this vector St is known to us as vector a2 minus vector a1. Using just trigonometry in the triangle SPT, the distance PT is nothing but St sine theta. So, I need to now use this, and replacing in the relation B cross vector St, I get B cross a2 minus a1 is equal to magnitude of the vector B into Pt, because vector St, magnitude of vector St is same as distance St. So, St sine theta gets replaced by the distance Pt times the unit vector. So, if I just equate the magnitude of the two sides, I will get magnitude of B cross a2 minus a1 to be same as magnitude of the vector B into distance Pt. And therefore, the shortest distance, which was Pt distance, becomes same as the magnitude of B cross a2 minus a1 divided by magnitude of the vector B. So, if I have the two lines given to us which are in the same direction, so I know the vector B, I know the vector A1 and A2, I can take this formula as a result to find the shortest distance between those two parallel lines. I hope today's lesson has made the task of finding shortest distance between skew lines a bit easier for you. Do take up a few more questions and make sure that you get the hang of it. All the best to all of you.